These videos are how to add and subtract fractions, both through modeling and finding mathematical equivalent denominators or like denominators. In order to model fractions, first you have to know what a unit fraction is, and that's a fraction where there is a 1 in the numerator, and the denominator is the total number of pieces. So this is a unit fraction 1/5. If I add 1/5 more, plus 1/5 more, plus 1/5, plus 1/5, I add all the numerators, and I have 1, 2, 3, 4, 5, 5/5, which happens to equal 1 whole. And that's where that whole number comes from. When modeling, use fraction circles. The circles will help you identify the unit fractions that you need to either add or to subtract. So let's take an example of 1/2. We have 1/2 of a pie left, and we want to add from another pie, we want to add, maybe there is 1/6 of that pie left. So how am I going to add these two together? Well, if I draw fraction circles, and I draw the fraction circles in sixths, I'll see that 1/2 of the pie is really equivalent to, this is half the pie, is really the equivalent to 3/6. And 1/6 of the pie, when I draw it in sixths, I will show that as one piece. So we want to put together now 1/6 plus 3/6. And when I add those together, since the denominators are already alike, all I have to do is add the numerators, and we're going to model that together also. So now I'm going to take the 3/6, plus the 1/6, and I'm going to put that together in a pie graph. So now we have the 3/6 plus the 1/6, and I want to put that into a fraction circle. And I divide my fraction circle in sixths. Now here's the first 3/6 of the pie, and now I'm going to add one more for the 1/6 that's there. And when I count them, 1, 2, 3, 4, this is going to equal 4/6. Notice the denominator does not change. The only thing we're adding is the numerators together, 3 plus 1 to equal 4/6. Now, if you remember from last lesson, we need to simplify this, or to put it into lowest terms, so I'm going to divide both the top and bottom by 2/2, if you recall, equals 1 whole, and we get 2/3. So 2/3 of the pie are left. We're going to subtract using modeling. And the first model that we make is always a rectangle, and it equals 1 whole, because remember, all the total pieces in the denominator have to equal 1. And each one of these unit fractions of sixths added together equals 6/6, or 1 whole. So now let's do some subtraction. So let's say we have 4/6, and we want to subtract 1/6 from that. And what I'm going to do to show that, first of all, I only need 1, 2, 3, 4, so I'm going to erase these. First thing I'm going to do is I'm going to draw in 4/6, so I have 4/6, and don't forget the other 2/6 that are really not here equal the 1 whole. So now I have 4/6, and I need to take away 1, and the way that we do that in modeling is usually we circle it and we put an X through it. So now once we do that, we know that we're going to take away that 1/6, and the number left is 1, 2, 3, 6. So that's how you see it in a model. And now if we subtract 4/6 from 1/6, remember the denominators are the same, so we do not subtract them. We only subtract the numerators to get the 3/6. So now we're going to add and subtract with unlike denominators. So I have two fractions, 3/12, and I want to add 4/8 to it. I can set it up as a model if I want. However, it's a lot easier to find the multiples of the denominators to find the common multiple. So the multiples of 12 are as follows. Now we find the multiples of 12 and 8. And the multiples for 12 are 12, 24, 36, 48, 60, and 72. I'm going to stop there. And the multiples of 8 are 8, 16, 24, 32, 40, 48, 56, and 64. And right away I can see that one set of multiples, or a common denominator in both, is going to be 48. So it's 48 I'm going to use to find my equivalent fractions and put them into like denominators. So now I know that the common denominator is 48. I make that my denominator right away, and you have to say to yourself, how many times does 12 go into 48? And the answer is 4, and I can not only multiply the denominator, I must also multiply the numerator. And remember, 4 over 4 equals 1 whole. So 4 times 3 is 12, and then the 4 times 12 is 48. On the other side, now I need to think, how many times does 8 go into 48? And I know that that is 6, so I need to use 6 over 6, and that's 24 over 48. Now I can add them together because the denominators are the same. I am not adding the denominators, I am only adding the numerators. So 24 plus 12 is 36 over 48. Now, 36 over 48 is not in simplest form, so I need to think about my times tables. I know they're both even numbers, so they'd be divisible by 2, but I also know that 12 goes into both, so I'm going to divide each by 12 over 12. 36 divided by 12 is 3, and 48 divided by 12 is 4. So my answer to this problem is 36 over 48, which equals 3/4. I can do the exact same thing when I am subtracting fractions that have unlike denominators. Let's try the subtraction problem 6/9 minus 1/3. Now, if you know your times tables, you know that 3 goes into 9. So I am not going to change the fraction 6/9. I'm going to leave it alone. But I am going to need to change the thirds. So I need to say how many 3's are there going to be in 9? What am I going to multiply by? And I know that 3 times 3 equals 9. So I must also do that to the numerator, and I get 3/9. When I subtract, now again, I am not subtracting the denominators. I am only subtracting numerators. 6 minus 3 equals 3, and it is over 9. Again, we're not in simplest form, because if I divide this by 3 over 3, I get 1/3. So my answer is 1/3.